Hello and welcome to Walking Talking Mocks with Budehaven Science. We're going to focus on how to make a salt. We'll look at the subject knowledge you need for this question. You will then be given time to answer a 6-mark question before looking at an example answer provided by me. To answer this question, all you'll need is paper, pen and something to time yourself with. A salt is a compound that forms when a substance, such as a metal, replaces the hydrogen in an acid. Your syllabus looks at 4 ways to make a salt where the hydrogen in the acid has been displaced. Acid plus alkali. You'll see this in a titration. Acid plus metal. Acid and an insoluble base, such as a metal oxide. You've seen this in your required practical. And finally, an acid plus a carbonate. You will notice that the products in these salt-forming reactions are all different. As well as knowing the products that form, you're expected to know the name of the salts that form within a reaction. There are 3 common acids used to make salts you should know, remembering that the end of the word changes after the reaction. Hydrochloric acid would form a chloride. Here in the example, you can see that the calcium is more reactive and therefore displaces the hydrogen and forms calcium chloride. You then have sulfuric acid, which forms a sulfate. In the example, we have used magnesium, which is more reactive than hydrogen. Therefore, it displaces the hydrogen and forms magnesium sulfate. Finally, there is nitric acid, which forms a nitrate salt. In this example, we've got potassium and nitric acid forming potassium nitrate and hydrogen. However, as I'm sure you remember from the reactivity series topic, a group 1 metal and acid is highly dangerous, so you won't have seen this salt made during a lesson. Something that you may have noticed from the diagrams used is that all salt compounds are ionic lattices. Therefore, they all have the same properties due to being tightly held by the electrostatic attraction between the positive metal and the negative non-metal. We will now look at how to make a salt. You will have made copper sulfate crystals for your required practical before. This would be using sulfuric acid and copper oxide to make copper sulfate crystals and water. There are 3 main stages to this process. I have included the key words at the bottom that you may wish to use during a description of the technique. The first part is dissolving. You add an excess mass of your solute to a fixed volume of a solvent. Here, the solute would be copper oxide powder and the solvent would be the sulfuric acid. It's important to use an excess amount of our copper oxide to neutralise all of the acid. The solution can then be heated to help the copper oxide to dissolve. Next, we would need to filter the solution. This is a stage that is most commonly missed, but it is essential, because it removes the excess copper oxide that has not dissolved, leaving just the salt and water in the solution. The residue is removed and the filtrate is taken to the next stage. The final stage is to evaporate the water from the solution to leave pure dry crystals. This should be done slowly over a low heat or with the evaporating dish over a boiling water so the crystals have time to form rather than being left with a powdery mess. Over to you. You can now pause the video. You have 6 minutes to complete an answer and an example answer will be followed by me. Here is the question. A student plans a method to prepare pure crystals of copper sulfate. The student's method is 1. Add 1 spatula of calcium carbonate to dilute hydrochloric acid in a beaker. When the fizzing stops, heat the solution with a Bunsen burner until all the liquid is gone. The method contains several errors and does not produce pure copper sulfate crystals. Explain improvements the student should make to the method so that pure crystals of copper sulfate are produced. The question asks you to explain. Explain is a high-level skill that expects you to give reasons for your answer. Therefore, words like because or so that should be used. Pause the video now. Upon reading this question, the first thing I do is try and identify the errors in the method. So straight away, I know they haven't used an excess of the solute. I've also noticed that they haven't filtered the solution, meaning if they had used the correct method, there would be solute left in the solution. The final thing I noticed, which should have been the first thing, but it's easily missed if you skim read, the wrong reactants have been used. so calcium carbonate and hydrochloric acid cannot form copper sulfate. Here is the example answer. Use different reactants. Copper carbonate or copper oxide and sulfuric acid should be used to form a solution of copper sulfate and water. Add the solute in excess to neutralise all of the acid. The solution should then be filtered to remove any copper carbonate that is still left in the solution. The solution should be gently heated until most of the water is removed and then pat dry with a tissue so that crystals can form properly. Note that in the answer, reasons have been given for changes in the method. Now look at the mark scheme that has been provided by your exam board. Note at the bottom it states that correct chemicals must be used to score 5 and 6. Therefore, even if your explanation of improvements is spot on, you'll miss the top marks if you fail to correct the use of wrong reactants. If you're still struggling with this topic, come and see your teacher or attend our Wednesday after-school revision sessions.